Good evening, students. Today we are going to learn about energy. What is energy? What are the various forms of energy? In that, the mechanical form of energy have to be learned in more detail. This mechanical form of energy can be kinetic energy or potential energy. Now, lastly, we have to learn about the law of conservation of energy. And then we have to prove that this law of conservation of energy is applicable for a free falling body, or in a free falling body the total energy always remains constant, or in a free falling body the energy is conserved. These are the topics that we are going to finish today. A student, very first, what is energy? A student, we have learned about the work. If you have good understanding of work, then energy is very easy, because energy is nothing but it is same as work but defined in a slightly different way. So energy is simply called as ability to do work or capacity to do work. Ability or capacity of what? Of whom? So this ability or capacity of a body. That's why we are always saying energy is possessed by your body. Like you are saying, you have money, means you are possessing something. You are possessing some money, means it is the quality associated with you. You are possessing the good understanding, good knowledge. Similarly, this energy is always possessed by any body. Okay? Or energy is always given by anybody. So a student, energy is nothing but it is the work or ability to do work by that body. So how much energy is possessed? That is measured in the term of the total work the body can do. Getting? So that's why to define this energy, so definition is very simple, but understanding is very vital. So the definition is, it is ability, sometimes also called as the capacity of a body to do work. Means energy is possessed by your body and is measured in the term of the total work the body can do when it is allowed so. That's why in short it is simply called as ability to do work is called as energy. But understand this carefully, because this energy is always measured in the term of the work the body can do. Like the complete explanation of this small definition. So a body is possessing energy. Means if the body is possessing energy, it simply means it can do work. So body is possessing energy and measured by its tendency, its ability or capacity to do work. A student, this ability or capacity is always expressed for the body for which we want to measure the energy, and it is measured in the term of or expressed in the term of work. Means to know how much energy the body have means how much work the body can do. It simply means that. Now So from here we can understand various things. This energy can loosely be called as similar to or same as work done by body. Or ability to do work by your body. So therefore, from here we can say that this energy have the same nature as that of the work. Therefore, energy will also be a scalar, as work is a scalar quantity. So right, energy is a scalar quantity as work or like work. So this was regarding the type of quantity. So energy is a scalar quantity, that we have to keep in mind. Another thing, coming to the unit, what will be the unit of energy? Here we are getting energy is nothing but it is same as the work. So unit of energy will be same as the unit of work. So unit of energy is same as of work. What we have learned? The unit of work is joule in SI unit and erg
CGS.
in CGS unit. Therefore, what is the SI unit of energy?
Joule.
Joule.
Energy is joule, denoted by J. Okay. And CGS unit of energy?
Erg.
Very good. It is the two things. And we are already knowing that there is a relation between joule and erg. 1 joule is 10 to the power 7 erg. This we are already knowing. This we had proved last. If you have any doubt, then please refer those videos. Okay, student? So this was all about the energy. Now we have to understand what are the various forms of energy. Means energy is possessed by a body or energy is contained in a body. Then how much energy is present inside that body? That we want to know. How much energy is present or possessed by a body? For that, we have to understand what are the various forms of energy first. After that, we will go for calculating the energy with the help of work done. Students, what are the various forms of energy? So right, forms, sometimes also called as type of energy. So there are various forms or various types of energy. Some of the popular one we are going to write here. The very first, you are knowing that the heat energy. How we are absorbing that heat energy? In which term? So heat energy is always experienced by observing the change in temperature. Means if the temperature is high, we are saying that, oh, heat is experienced. Means every form of energy can be experienced. That is one thing. So right, very first that we are commonly coming across is the light energy. How we are understanding light is an energy? Light enables us, or a light allows us to see something. And light have the tendency to impart energy to particular body, say the electrons, to move it to higher state, though that cannot be experienced. So this way, every form of energy have some tendency to do the work. So right, light energy. This light energy, what is the source? Yes, student. Most commonly from sun, another any electric bulb, electric lamp. It is various source of light energy. So light enables us to see anything. Another heat energy. So where we are getting? Even from sun also.
Burning.
In addition to light, yes, burning fuel. Burning fuel or anything while you are burning, that gives the heat. Your electric heater, electric heaters, even the bulb is also giving etc. Another, the battery that you are using for getting the light, then battery contain which form of energy? Inside the battery, the energy is stored in the chemical form. So that is the chemical. So chemical energy is present inside the battery or the cell. Though while connecting this battery or cell with an external electric lamp, the lamp starts glowing. So there this chemical energy changes into electrical energy. But inside the battery, the energy is present in the chemical form. So there are various types of energy, students. The energy that we are obtaining from the stored water, that contain the potential, sometimes also called as hydel energy. So there are various kinds of energy, but broadly, just for your understanding, even the fuel, the inside the fuel, the energy is present in the chemical form, but while we are burning it, it gets converted into heat and light, and the ash that is left. The next one is called as the mechanical energy. Mechanical energy is the energy possessed by any moving body or a stationary body because of its position. Like if you have a balloon and if you want to compress it, then you will experience an upward force. Or even after compressing, you are leaving it, you try to regain its shape. Means what? It had the tendency to regain itself. It had the tendency to do that work to attain its original shape. So these are the ability or tendency in terms of which the energy can be measured. So this mechanical energy is what? It is the energy in a moving body. Like if a car is moving, it have the mechanical energy. That particular form of energy because of motion is called kinetic energy. That we will learn in detail. It is not only that much, even the fan hanging over your head, that fan also possesses mechanical energy. That mechanical energy is called potential energy. How you can say that fan is possessing mechanical energy? A student, as long as the fan is held by the hinge in the ceiling, it is hanging. If the hinge is broken, then what will happen? Then you are observing that if the hinge get broken at that time, the fan will fall downward. Means if the fan is allowed to leave its position, then it will surely move down. So while it start moving down, and if it fall on your head will be broken. Means what? The fan have tendency to do work. It means the fan have the tendency to get displaced, and while displacing it can exert the force over other body. Therefore this force and displacement can give us the work done. This way the work done can give us the energy. So this mechanical energy are of the two type. So this is the energy in a moving body, or a body, or in a body due to its configuration, or right due to its configuration or position, we can write. Say the fan is at ceiling, then it have the tendency to move down to put a force and break your head or the floor. But if it is already laying at the floor, it do not have tendency to move further as long as the ceiling is intact. Say you are on the first floor. If you are on the ground, it cannot move further down. Get it? So because of this height, it is called its position or its configuration. So this configuration gives the tendency to do work. So energy in a body or due to its position or configuration. So this configuration word is important. This you have to keep in mind. So based on this, the energy in a moving body is called as kinetic energy, and energy in a body due to its position gives the potential energy. Therefore, sometimes mechanical energy is also defined as sum of kinetic energy and potential energy. So, right, mechanical energy, we have to learn in more detail about this mechanical energy. What is this mechanical energy? Let us continue with mechanical energy. A student, this mechanical energy is sum of potential energy and kinetic energy. So it is sum of or total of kinetic energy and potential energy. Means it is due to either motion of body or due to configuration of body. So right, it is due to motion of body or configuration of body. To motion of a body or due to configuration or position . Configuration means the position. Like if you are twisting and spring, it will get a new position. That new position is called configuration of a body. If the energy is due to motion, it is called as your kinetic energy. And if it is due to position, it is called as potential energy. Means the mechanical energy can be of two types. So let us write mechanical energy can be divided into two type. The very first, let us write the kinetic energy. Let us divide it, and let us first write the broader difference, then we will write the derive their formula also. The very first, this mechanical energy can be due to motion of a body, so that is called as the kinetic energy. And the second one is due to its position, so called potential energy. It's very easy chapter, just you have to understand. A student, this kinetic, the term kinetic already we have learned since the first chapter of physics. Kinematics means the motion. So kinetic always means the motion. And potential means it had the tendency simply. Get it? So it is because of the position, or also called as configuration, or sometimes also called as state. So this state means a state of rest or particular orientation, that is called as the state here. So what is this kinetic energy? Kinetic energy simply means, the definition wise, kinetic energy, it is the energy. This is the definition you have to keep in mind, student. I will not rewrite this definition at other places. So it is energy possessed by your body due to motion. Means if the body is in motion, it have kinetic energy. If the body do not have motion, it do not have kinetic energy. It's so simple. So definition is this much only. It is the energy possessed by a body due to motion. Means because of motion, this energy arises. If no motion, then no kinetic energy. So if a body in motion, this implies it has kinetic energy. In addition to kinetic energy, it may also have some potential energy. Say if a body is moving on the ground, it have only kinetic energy. But if the body is flying, say birds are flying, then while it is flying at certain height, because of its motion, it have kinetic energy. And because of its height from the ground, because of its position from the ground level, it have potential energy also. Okay? So if a body in motion, it has kinetic energy in addition to other, if any, in addition to other form of energy, if any, other energy, if any. It is very much sure that if the body is in motion, surely it will have kinetic energy. Though it may have some other form of energy, or it may possess or may not possess. If body at rest, what does it mean? It has kinetic energy. It do not have kinetic energy. Getting? That is, kinetic energy of that body is 0. It simply means this kinetic energy can surely be expressed in the term of its velocity or its speed. The formula for this kinetic energy is like this. This we will drive also. So kinetic energy Ke is given by half mass into its velocity or speed square. It is this much simple. We have to keep in mind Ke denotes the kinetic energy. So this Ke, sometimes student it is also denoted as E with K in suffix. Ek means energy because of kinetic, because of motion. It is called as kinetic energy. Here M denotes what? A body which
Mass.
is possessing some mass. It is the mass of the body,
Mass.
and V is the speed basically, or the
Speed.
velocity, magnitude of velocity you may call, or it is the speed of the body, or magnitude of velocity of the body. These things we have to keep in mind, student. So here we are observing, if V is equals to 0, what does it mean? What is the value of kinetic energy? Half mass into 0 square. It becomes
Square.
0.
0.
So this way, if the body at rest, rest simply means its speed is 0.
0.
Therefore, it do not possess any kinetic energy. So from this formula, we can also verify. Okay, student? So it was about the kinetic energy. What is the unit of kinetic energy? Since it is energy, so unit will same. Okay, means the joule or earth. So here we are observing that the body is in motion, then it possesses the kinetic energy. What could be the example? Example could be moving car.
A car moving on a road.
Car, yes. Running dog. Running dog on the ground. Flying birds. Flying birds. Even the moving bullet. The bullet once fired from the gun, it attains kinetic energy. Okay, student? So, a student, here it is interesting that a flying bird, it have the kinetic energy and it also have the potential energy because of the height. So, let us come back to the potential energy. Then we will write, then we will derive the formula for the two. Definition wise, this potential energy is also very simple. So it is energy possessed by your body due to its position or configuration. So student, it is energy possessed by your body. What is the cause? The cause is
Due to its position.
position or configuration. So therefore we are writing it is the energy possessed by a body due to its position
Position.
or called as configuration. Sometimes also called as orientation. It is this one. Let us understand. It is very simple provided once you understand this. What is the position? Let us consider this is the ground level. On ground, a ball is there. or an object is there, say it is at rest, does this ball have or this object have tendency to move by itself?
No.
Yes, student?
No.
No. Very good. So this mass or this object on this ground will remain here on the ground. But if this mass is lifted to certain height, say you might have lifted the small object from this ground to certain height. Okay, student? At that time, means we may consider like this. Say a small object we have. Let us consider this is the ground level and an object is here. Consider this as the ground. Then this will not move. But by the way, if you have lifted this object upward from this ground level, at that time, if you leave this object from your hand, it have the tendency to automatically fall downward. Means the tendency to do something by itself is called what? Energy. It means,
Yes, sir.
this new state where the mass is lifted to certain height h, at this time it have energy, because once if it is left from this height, it will automatically fall downward. So this energy means here at this state it have energy. Energy is not equals to 0. But here we can say
Energy is 0.
energy is
Energy
0.
0.
Yes, here
Energy-
we are considering the body is also not moving. Means velocity is or speed is 0 for an object on ground. In second case, we have taken the object at certain height. So what is the cause of this energy? In second case, it is the height. So height is the cause. Height h is the cause. Means this height means it is the position. It is one thing that we have learned. Now, a student, if we consider the other example, let us consider you have an spring of this much. Means naturally you have taken the spring from your pen and it is of this much length only. Okay, so this is the natural length of or normal length of spring, L normal. So it is the normal length. But by the way, if you have hold this or fix this and you have pulled it like this, now it is what? Stretched. So this much is stretched. Now if you leave this end, as long as you are holding it in your hand, it will remain stretched. If you leave it, it will try to come back. Means what? Because of this stretched is called as elongation. Means increase in length. It have tendency to move backward, to return to its initial position. So this tendency means if the object have some tendency to do certain thing, then it possesses energy. It means elongated spring possesses energy. It need not be elongated only. Even if you are compressing this spring, so just fix one of the end, compressing this spring, just one coil touching the other. So from the normal length, you have reduced the length. So this is the length which is being decreased. When this can happen, when you have pushed it inward.
Pushed.
So this is called as the compression or compressed spring. So this is our spring or a slinky, sometimes also called as slinky. If it is made up of plastic and made up of iron, then it is, or metal is called spring. Okay, student. So this means a coil or spring have tendency to gain its original shape. Once it is either elongated or compressed, it possesses energy so that it try to come back. It is the second one. A student, other we may also take, say, a bow and arrow. Let me draw next. Students, let us take one more example. So a bow, when stretched, you are knowing that bow and arrow. Let us consider this is the bow under normal condition. But if you are trying to stretch it, means stretching, while you try to put an arrow over it and you will pull it backward, then what will happen? Is this only string which get elongated along with certain portion of the certain other portion, the new position appear like this. So you can see the new position appear like this. I am drawing the new position. So this is our new position where the arrow have came like this. Getting? So this new position, when the bow get elongated, so this elongated string of the bow contain potential energy, means a stretched string simply get the potential. This string when stretched, then it gains potential energy because of change in its position. Once if you leave this string, the arrow will try to move forward. So this way, on leaving, so right here, the stretched thread or string of bow have which kind of energy? Potential energy because of its configuration, means the stretching. Get it? On leaving, so leave, or you just lose your hand so that the string can come out your hand. The stretched string means here you have hold it. If you are leaving it, then this will, the arrow will try to move forward and it will be pushed far away from the bow. So leave it makes the two things. String comes to normal, comes or tries to comes to original position, original shape. So it was because of the change in shape this potential energy arises. Also, if the arrow was there, if arrow on the string, on the stretched string, then what will happen? Where the arrow will go? Which kind of energy will be possessed by arrow once if it is fired?
Kinetic energy.
Good. So if arrow on the stretched string is fired means lift, then arrow gains or gets kinetic energy, because it's as it starts moving, and a moving body always possesses kinetic energy. So kinetic energy is possessed by the fired arrow. Get it? While the stretched string of the bow possesses potential energy. So write to the point. A stretched string of bow have potential energy, while the fired arrow have kinetic energy, like like the bullet of the gun. Though inside the gun there is a spring, okay, that spring also possesses the kinetic energy, because the spring is present in compressed form. So here what we have observed regarding the potential energy. So the potential energy, so right here, potential energy can be due to, so from first example what we have observed, due to height or position, due to height from ground, also called as the position. And we will see that this potential energy is measured by mass of the object into acceleration due to gravity into height h. This we will derive after few minutes. The second, rather than height, it can be due to the orientation of a spring, okay, like a spring is compressed or elongated or even twisted. So right, orientation of a spring.
Sir, orientation of rubber band.
Yeah, exactly, very good. So orientation of a spring or slinky or rubber, so it can be, this orientation can be elongated or maybe compressed. Compressed means the length is shortened, or maybe twisted, like you are twisting something, okay. So twisted. So these are the three conditions for the orientation. Like in the clock, the spring get twisted. Earlier days there were the clock in which you have to rotate the key, and after every 24 hours you have to give the key. Like in your clock having the alarm, not this simple beep alarm, but the alarm of the spring loaded alarm. In that the spring is twisted, and once the time is reached, the spring start open, and that gives the sound. So it was the second one. The third one is because of this tension, means the stretching is called as your tension. More you will learn in higher standard. So right, C is, so this potential energy can be due to height, due to orientation, or due to tension or stretched, or tension in string, like the bow. So these are the cause for potential energy. So when potential energy can happen, if such situations are occurring, then the potential energy is possessed. Few more example of potential energy. Let us understand. Say the water stored in dam. Water stored in dam or hydel plant. Hydel plant. Like our Kadra plant that you are knowing that. What is happening there? Student, so there is a big dam, and on one side you are observing there is a reservoir and that contain water. Did you observe our Kadra dam? So water to certain height. You might have gone over the dam many times because the road is going over that. And you are observing that on the other side, the water is at very low, just there is a river. So student, if there is an opening at this position, then water will try to come out. So if the water is above the ground level, means this is the height of the water. So because of height of the water, water tries to fall downward. So what is the energy possessed by this water which is on the reservoir side? It is the potential energy. Are you getting? So if any object have energy because of height, that energy is potential energy. And water is stored in the dam. If there is an opening, then this water have the tendency to move downward. So this tendency is what? Ability to do work, means it possesses the energy. Which kind of energy? Potential energy. Are you getting? So water is stored in dam have potential energy. This you have to keep in mind. It is asked many times. Getting? So these are the things that we need to keep in mind. Like in bow and arrow, so a straight string have the potential energy, but fired arrow or moving arrow have the kinetic energy. So this is potential energy. We will drive MGH later on. Now let us come to the derivation of kinetic energy. Yeah, tell me.
Can you scroll up?
It is already at the bottom. Getting?
Yes, sir. Writing.
So now let us go for driving the formula. Like kinetic energy is half mva square and potential energy is given by mgh. These two things we are going to derive. Okay, students, can I go?
Yes, sir.
Students, so this was about our potential energy. Everything what we have written on the right side is for the potential energy, and on left hand side we are writing for kinetic energy. A student, on previous page we have learned that this kinetic energy is given by half mva square. So this formula, this is very important formula, and we have to derive this. It is very important. Derivation is also asked. So let us go for deriving this formula. Very easy derivation. So right, I am deriving here. So derivation of kinetic energy is given by half mva square. This one we want to derive. A student, here the body is moving. Getting now? It means, let us consider only the kinetic energy. Consider an object on the ground. This is the ball. Okay? This ball have some mass. M is the mass of this ball. Initially, it might be moving with some speed or maybe at rest. So you are free to choose. Let us consider initially the ball was moving with speed u. And from the Newton's first law of motion, we have learned that this body or this ball will continue to move with same speed unless or until any external force is applied. Get it? So to change its speed, we need to apply some force. So let us consider an external force F is applied over this mass or over this ball, so that after certain time its speed have reached to final velocity or final speed v, though the mass m remains unchanged. Because of this force on this ball, it will attain an acceleration. There will be an acceleration in this ball. How much will be the acceleration? Acceleration is obtained by dividing the force, means the applied force, with the mass of the body on which the force is applied. So this much will be the acceleration. Let us consider, while this force is applied and the body attained speed v, it have covered a distance of d, or let me denote it by s. So s is the distance covered by the body. Now, if we want to calculate the work done, how I can calculate? F into s. But by kinetic equation, we can bring a relation between u, v and s. Though s is same, means one can be substituted in other. That we are going to apply. So student, right here, let a body of mass m have initial speed. A student, we are free to choose initial speed as u or maybe 0 also. Okay, if the body starts from the rest. So you may write in the bracket itself, maybe 0 for rest. Means if the body is initially at rest, then we shall take u is equals to 0. So let a body of mass m have initial speed u is acted by a constant force. That constant force we are denoting here F. So what are the denotation? It is very important to understand. Acted by a constant force, due to which, because of this force, the body will move forward so that the work can be calculated. Also, because of the force, there will be acceleration, so speed will change. Due to which the body moves, displacement s, and attained final speed v. Okay, these are the things, these are the phenomena that is happening when the force F is applied. Now, because of the applied force and the displacement, how much work will be there? So right now, because of F and S, since the force is there and this force have displaced the body by displacement S, how much is the work done? Work done by this force or work done by the body is how much? It is denoted by W and it is given by F into S. That is W is equals to F into S. So let me take this as equation 1. Okay, student. Now, because of this force, this much work is done. Means the body had tendency to do this much work. That tendency itself is the measure of energy. So this work done is always expressed or given in the term of energy. Okay, so this will give us nothing but the energy itself. Energy, and it is because of the motion, because of the speed change. So this work done is due to motion, therefore it will be kinetic energy. Let me write like this. So write this work done is due to motion. Means the speed have changed. Therefore, it gives which kind of energy? Yes, student? It gives kinetic energy. Very good. So from this, we can see that even the kinetic energy here can be calculated by F into S. We can say like that. But what is F and what is S here? Also, or we may take this as 1. Both are the same thing. Also, by kinematic relation, we are knowing that V square is given by U square plus 2AS, because in this case we have applied force which give rise to acceleration A. So body is moving with a constant acceleration and it have covered distance S. So the speed have changed from U to V. So there will be a relation between U, V, S and A. That can be written like this. Or just rearranging this, V square minus U square is equals to 2AS. This can be written. Or what is this value of A, student? This value of A can be calculated by F by M into S. Can we say like that or not? Or even if you have any doubt, you can leave it rather than rearranging. If you are having doubt, then you just calculate the S here. S is given by V square minus U square by 2A. Take this as 2. Now substitute this S here. What we can get? Yes, student. So therefore, using 2 in 1, we can get kinetic energy or the work done can be written as, or right now one may write as the work done itself. That doesn't make any sense or any difference because this work done is same as the kinetic energy. So work done is given by F into S. So F, in place of S, we are substituting V square minus U square by 2A. Student, this is multiplied with entire F. So just rearrange this. Take this 1 by 2 outside, F by A in one bracket, then V square minus U square in the other bracket. But student, here what we are knowing that there is a relation between Fm and A. F is equals to mass into acceleration. Therefore, this F can be replaced by, in numerator, force can be given by mass into acceleration divided by acceleration into V square minus U square. It is inside the bracket. This A can be cancelled. So here it can be written as half of V square minus U square. Are you getting? This is the work done. So here this work done may be denoted by W itself as we has taken, or this may be called as the kinetic energy, but
Sir.
we shall understand. Yes, tell me.
Sir, it will be half M bracket V square
Yeah, it
minus
is
U.
M here. M is not printed. M is here. Only A is being cancelled, so M is there. Okay, half M bracket V square minus U square. Let me copy this on the next page to understand more. So therefore, this work done is given by half M V square minus U square. A student, this is the relation that we have obtained. Even this can be separated as W as half M V square minus half M U square. Okay, a student, what is this? V is your final speed or final velocity. U is your initial speed or initial velocity. Therefore, this half mv square can give us what? Final kinetic energy. This may be written as initial kinetic energy. So therefore, we may denote this work done as KEF final minus KE initial. Means this work done is equals to, what is this? Something final minus initial is called a change. So it is given a change in kinetic energy. It is one formula that we are applying. That total work done is obtained by taking their change in kinetic energy. Now, a student, if the body started from the rest, then how much is the kinetic energy the body have attained? That we are going to derive. Yes.
Can you show last page?
See, on left hand side we have derived for the kinetic energy, and on right hand side we have for the potential energy. So do not get confused. This one?
Yes, sir.
Yeah, write it.
Yes, sir. Over.
So this way we have observed that this kinetic energy or the change in kinetic energy gives the work done by the body. So how much work is done by a body? That can be obtained by obtaining the change in kinetic energy. That is from this relation, student. So work done by a body is change in its kinetic energy. It is one thing. Another thing, if body at rest or started from rest, if body started from rest, then what does it mean? It simply means u is equals to 0. Therefore, the work done by your body is given by half m v square minus 0 square. So this is half m v square. Means the entire work done or capacity or maximum work done by your body is half mv square. So this is maximum work. So it is the maximum work done expressed in the term of its energy due to motion. So this is the kinetic energy. So therefore, simply kinetic energy is obtained, or kinetic energy possessed by your body is obtained by taking half mv square. From here we have learned two things. One is change in kinetic energy can give us the work done. Another one, the kinetic energy itself is calculated by half mv square. These are the two things that we have understood from this derivation. A student, now in parallel, let us go for calculating the potential energy due to a body at certain height. Then we will do one numerical on each. Then we will stop the class. Today, perhaps we could not finish the law of conservation. So, law of conservation, then the power. Power is very small topic. Those two things we will finish tomorrow. So, students, this was about the kinetic energy. Now, let us come for the potential energy of a body at certain height in this gravitation, in this gravitational field. So right, potential energy of a body near to Earth's surface, near to Earth surface, but not on the Earth's surface. It is near to Earth's surface and it is at height h. Why we are taking near to Earth's surface? If it is at very high, then this g varies, means
Sir,
hello.
Yes, sir.
Okay, any doubt? So, student, let us consider an object at certain height from the ground. This is the ground level, and an object is at certain height h. This object have mass m. It is at height. We have learned that if this object is on the ground, then it do not possess any potential energy. Okay, it do not have any tendency to move further. But if the object is at certain height, then you are releasing an object from certain height, then it has the tendency to move down. Are you getting? So because of this tendency, it is possessing the energy. Means when it was at height, it was possessing some energy, but when it is released from that height, that energy get converted into kinetic energy. Though the total energy remains the same, that we will learn in our law of conservation. But if the body is at height h, then what is the maximum work this body can do? That we want to calculate. So for calculating the work, we need to know how much force is acting over the body. So student, how much force because of certain height near to Earth's surface, how much force is acting on the body? Always, any body is always acted by its weight. mg. Student, last day we have also done such kind of questions. Force acting is due to weight, and this is given by m into g. Is it okay? So this force is always acting. Say, if I leave this object, why it falls downward? Because of its weight. So even I am holding it, still the weight is acting downward. I am holding it, so that mg is balanced by me. So this mg is acting downward. Now, when the body is released, how much distance this body can cover? Yes, student, if the body is allowed to leave, very good. Finally, the body will come at this position. Okay, so write, let a body of mass m is at height h above the ground, therefore force acting on body, force acting on body is always equals to its weight, and this weight is given by mass into acceleration due to gravity mg. Now, when the body is left or allowed to move, it will cover a distance h itself. So right, when body is allowed to move, it will cover displacement how much?
Height.
Good. H. So this way the force mg is known and displacement is known. Therefore, what is the maximum work done by a body? So the maximum
mgh.
work done by this body can be calculated by taking its weight into the height it can move. So here we have taken this as mg and
mgh.
height as h. So this maximum work the body can do is called what? Potential energy, because this energy is because of the height initially it was having. So therefore this potential energy is given by mgh. This is the formula. Okay, student, it's so simple kind of thing, but we have to keep in mind the same thing even we had also done last day. So here what is the denotation? Denotations are very simple, where this PE denotes potential energy, gives us potential energy, and M is what? Mass of the body. G is what? Acceleration due to gravity. And H is what? Height from the ground. Height from ground. So sometimes this ground also called as a reference level, up to which the body can move if it is allowed so. So student, if H is equals to 0, what does it mean? Does the body have any potential energy?
No.
No.
Mg into 0, it becomes 0. So
Sir,
no.
acceleration due to gravity, the quantity will be 10 meter per second.
Yeah, it is your 10 meter per second square, student. The same G that we have learned last. Same denotation for kinetic energy. Here, half is a constant factor. And what is this Ke? What denotes? It is called as kinetic energy.
Kinetic energy.
Yes. What this M denotes here? Mass of the body. Whose kinetic energy we want to calculate. And V denotes what? The speed of the body. So the kinetic energy is always calculated at particular instant when the speed is possessed. Also, potential energy is also calculated at certain instant for a specific height, because if h varies, the potential energy varies. As the v varies, the kinetic energy will vary. Okay, student. So this was all about the formula. Now let us solve one of the question. Write down a question, student. A body is moving at a speed of 72 kilometer per hour, then find its kinetic energy. Yeah, only this much simple. A body of mass, let me take a body of 5 kg, let me take mass I have given as the 5 kg. So body of 5 kg is moving at the speed of 72 kilometer per hour. Then what is the kinetic energy? So unit is important here, student. What are the given data? It is given that there must be some body whose speed is given as 72 kph, and the mass of this body is 5 kg. Student, how the kinetic energy is calculated? Ek or Ke is calculated by half mv square. So shall we substitute directly? Yeah, can we substitute as it is, or any changes we have to do? Student, what is the unit of speed? Kilometer per hour. But in SI unit, the speed should be in meter per second. So you need to change it. That is the important thing here you have to do. So it is 72 into 1000 divided by 60 into 60. This become meter in numerator, and in denominator it has become second. So cancel this. The 20 cancelled. 12. So this is also cancelled 2 times. So it becomes 20 meter per second. So we have to substitute 20. Are you getting? This is very important. Then only we can write the unit as joule. If you are substituting 72, that will not give you joule or any other unit like erg. So here we have to substitute 20 square. So 5 into 400 by 2. So it becomes 200. So 5 2s are 10,000 joule is the answer. And if there is anything 1000, that is called as kilojoule. The term kilo is added. So it is this much. Okay. So questions are very simple, student. Let me take one more question. So a body is moving initially at say 20 meter per second, and after some time its speed reduced to 5 meter per second, then find the work done by the body. Yes. Have mass of 5 kg, initially moving 20 meter per second, but after some time the speed have reduced. So what we have learned? Work done by the body. You can draw like this. Initially the speed was your 20 meter per second. You may call this as V1 as 20 meter per second. And after some time the speed V2 become 5 meter per second. This is the situation. The mass remains the same, means the mass is 5 kg. So mass do not varies. Then you have to calculate how much work it have done. Just we had learned that the work done is obtained by calculating the kinetic energy at this position and kinetic energy at this position. Take their difference. That will give us the work done. Okay, student? Just we had learned. So, right? See, this was the condition. Work done is obtained by calculating the change in kinetic energy. How much kinetic energy have changed? Means the final minus initial or initial minus final. But the important thing, if the body itself is doing some work, means its energy is going to reduce. We shall take initial minus final. So, right, work done by body is equals to initial kinetic energy of body, initial kinetic energy minus the final kinetic energy. This is by the body. The body have done the work. Therefore, we shall take the initial first and final next. So, how much work is done? This is, you may write, kinetic energy initial was the 1 minus kinetic energy, the final is 2. So, substitute half m v1 square minus half m v2 square. Just substitute it here. Half m can be taken out. v1 square minus v2 square. Substitute the values. Mass is given as 5. v1 is our 20 and v2 is 5. So 20 square minus 5 square you may take. So it is like our 5 by 2. So this you can write this as a square plus b square. Sorry, a square minus b square. So a plus b into a minus b. You may write this as 25 into 15. Or just finally you may do like this also. That depends on your calculation only. Into, inside the bracket it is 400 minus 5 is 25. So 5 into 375 by 2. It's simply this much. So how much is this? So just multiply this 375 by 0 by 4. So divide it 9 times 36, then 1 5, 4 times 12, then so this way 15 is reduced, 3 is still left, so 3 0 30, 7 time 28. Now it become like point, then still 2, so it become like our 5. This much joule is the answer. It's so simple. It is nothing but it's a simple calculation. I have multiplied numerator and denominator by 2 so that this can easily be divided or calculated. Multiply that.
Sir.
Yes?
937.5.
9, yeah, it is 3 rather than 4, it is 3. Exact, correct. 937.5 is the answer. Okay, student, it is like this. So questions are very easy. Similarly, let me take one question from the potential energy. So student, find the potential energy of a bird sitting on a tree or flying, maybe flying. If its speed is given, then it also possesses the kinetic energy. Bird at height of mass 500 gram at height of at height of 80 meter above the ground. So the body is there, whether it is flying or not. If flying is there, then it have the kinetic energy also, but that is not asked here. Here simply given as it have the mass of 500 gram. Student, first you shall take care of the unit. So it means it is 0.5 kg, half kg. This height is given h as 80 meter. So right here, what are given thing? Mass is equals to 500 gram, means 0.5 kg, and height is 80 meter. Since G is already 10,
meter.
very good. Since potential energy is given by how much?
MGA.
Good, mgh. So we can just calculate it. So half, no half is there, so substitute. M is 0.5, so you may put at half or direct 0.5 itself, into G is 10 into 80. Okay, student? Yes. So it is 400. Simply that much. 400 joule. Okay, student? By the way, in the same question, so in above question, if the bird is flying, means at the same height, okay, no?
Sir. Yes, sir, speaking. Hello. सर चले गए. Hello.
Sorry, student, it was a network issues, so that's why it got disconnected. See, students, we were discussing that a bird is flying at a speed of 8 meter per second at height of 80 meter. Then we have to calculate the total energy. A student, we need here the total energy. Say the mass of this bird is half kg or 0.5 kg. It is moving with a speed of 8 meter per second. While the body is moving with a speed of 8 meter per second, it means it possesses kinetic energy. And that kinetic energy is calculated by half mva square. So substitute it. Half m is 0.5 into v is your 8 square. So it is like half into 0.5 into 8 into 8. It simply means that. Cancel it. So it is like our 4, even 0.5 and 4 become 2. So it become like our 16 of joule. So this is the kinetic energy, 16 joule, because of its motion, because it is flying at 8 meter per second. Another, since the bird is also at certain height, so because of its height, it possesses potential energy, and potential energy is given by mgh. So substitute, mass is 0.5, g is 10, and height is your 80.
80.
Yeah, so just substitute it. It become 5 into 8, 400 joule. So this way, the two kind of energy, one is kinetic, another potential, is obtained. Therefore, what is the total energy possessed by a bird, by this bird? Yes, student. Yes.
16 joules plus 400 joules.
Good. So that is obtained, is given by the addition of its kinetic energy because of its
416.
speed and its potential energy also. So it is like our 16 plus 400. So this become 416 joule. This is the answer. Okay, student. So this was all about today class. This is very important question which explain the body can have both potential as well as the kinetic energy at the same time. Okay, student? So write a note. A body may have potential energy and kinetic energy at the same time, or only one at a time, or only one at a time. It depends on the situation. If the bird was sitting at that much height over a tree or something else, then it do not possess the kinetic energy. It has only potential. Okay, so this was all about. Now it is the time for your homework. So please do your textbook questions. How much you people can do? So you people please read this chapter carefully. Then after reading, see a student, we had already done these questions yesterday. Today I had explained you what is kinetic energy along with the derivation, this potential energy also. So student, this question on your page number 152 you can do. As well as the other part we have to do tomorrow. So student, right now you have to do only this much question. Okay, so this is regarding our blue question on page number 152, because on next blue question it contains the law of conservation of energy. Tomorrow we will learn about the law of conservation of energy, and by that we will be able to finish our chapter also by tomorrow itself. Yes student, any doubt then please